Hello there, and welcome to the second classwork. Here is the essential question: how can we solve quadratics of the form x squared plus bx plus c by looking for patterns? And just like before, there's still a magical one right there. So we're still looking at situations where a equals 1. Write this down in your notes. Make sure you have this because you should be able to answer this by the end of the day. So before I start talking about anything, I want to introduce to you my friend, the zero product property. Now we're going to use this. I don't know if you know that it's called the zero product property, but pretty much what it tells us is that, let me actually move this around. After factoring, for example, let's say we end up with something like x plus 5 and x plus 2 equals 0. Now I'm sure y'all know where I'm going to go with this, but let's say we end up with that. What the zero property tells us is that if the product of two expressions, in this case x plus 5 and x plus 2 is 0, then one of them or both of them must equal 0. So this is why we can do this little thing where we kind of set each one equal to 0, x plus 5 equals 0, and x plus 2 equals 0. Now, when in this classwork, we're going to do the exact same thing from last classwork, except we're going to have an equation where it's set equal to 0. Now when you solve this, you do minus 5. Minus 5, you get x equals negative 5. That's one answer. Minus 2, x equals negative 2. And that's your second answer. So again, I just wanted to tell you why this makes sense and why we can do this. Because if you think about it, if two things multiplied equals 0, the only thing that multiplied, when you multiply stuff equals 0 is 0, because 0 times anything is 0. So, let's get to the example. Okay, so here's our first example. Solve the following equation: x squared minus 5x minus 14 equals 0. Now before you freak out, don't even worry about that equals 0 part. Just ignore that right now. How did we do this last time? Who remembers? Probably were thinking it. You set the x method. Negative 14 goes on top. Negative 5 goes on the bottom. Now we want to look at two numbers that when you multiply them, you get 14, but when you add them, you get 5, negative 5. So what two numbers? I can think of negative 7 and positive 2. Negative 7 times positive 2 is 14, negative 7 plus positive 2 is negative 5. So that's it actually, negative 7 and positive 2. Let me write those in here. Negative 7 and positive 2. Now to rewrite this, we write this into binomials. Remember the two different expressions? You do x minus 7. Make sure you write this in red. And x plus 2. Now here's where our little friend, the zero product property, comes in. Because we originally had this equals 0. So because we have two expressions, two different numbers that when multiplied equals 0, can actually use that to split it. And I usually just draw a little arrow over here. Say x minus 7 equals 0. Draw a little arrow over here. X plus 2 equals 0. And solve. So let's look at the red one first. That plus 7, x equals 7. That's one of our answers. Minus 2, x equals negative 2. And that's our second answer. That's actually it. Now let's review everything we just did. First thing up here is, just like before, use the x method to factor the quadratic into two different binomials. In this case, x minus 7 and x plus 2. Right after that was use the zero product property, set each one equal to 0, and solve. So you're going to get x equals 7 and x equals negative 2. Piece of cake, huh? Here's our fun fact of the day. Did you know that the sun evaporates about 1 trillion tons of gallon a day? That is so much water that we're losing because of the sun, but it all comes back in rain. Here is our second example. Solve the following equation: x squared minus 8x plus 12 equals 0. Now if you feel super confident, if you're like, I know how to do this, don't worry about this example. Move on to the classwork and go ahead and try that. For those of you that want a little additional help, here's this example. Again, remember it's also in the notes. So the first thing you want to do is look at this left side and just let's factor that. Now, probably going to get tired of me saying this, but let's do the x, where positive 12 goes on top and negative 8 goes on bottom. Now again, we want to look at two numbers that when you multiply, you get 12, but when you add them, you get negative 8. So this one's going to be a little trickier. We're going to probably need two negative numbers. What goes into 12? Well, I know 6 and 2 goes into 12, but also negative 6 and negative 2 goes into 12. When you add negative 6 plus negative 2, you get negative 8. So those are actually going to be our factors. Let me write those down. Negative 6 and negative 2. So we're done with step 1. That was easy. Factor it, use a tree, use whatever you want to do. Step 2, write the binomials. Again, I'm going to color code it for you. In this case, they're both negative, so they're both going to be minus. Equals 0. Now, thanks to our friend, the zero product property, split that. X minus 6 equals 0. Plus 6 plus 6. X equals positive 6. There's one of our solutions. Split that one too. X minus 2 equals 0. Starting to get the hang of it. Add 2 to both sides. X equals positive 2. And that's it. So again, just to summarize everything. Step 1, factor the expression on the left. Step 2, set up the two binomials, set each one equal to 0, and solve. So if you still want some more examples, please let me know. Raise your hand. I'll go over, give you a mini lesson, show you what to do for this. Besides that, good luck with the classwork and have fun.